Hey there! Today, we're diving into the fascinating world of thermodynamics to explore two concepts that are closely related but often confused: heat energy and temperature. Let's break it down. First up is heat energy, also known as thermal energy. This is the energy that comes from the movement of atoms or molecules within a substance. The faster these particles move, the more heat energy they have. Heat energy can be transferred from one object to another. It can cause a change in temperature or even a phase change, like melting ice into water or boiling water into steam. Let's break it down further. Heat is the total energy of all the molecular motion inside an object. It depends on the number of particles, the type of particles, and their speed. It is like counting every single dollar in your piggy bank. Each coin contributes to the total sum. Visualize a piggy bank filling up with coins, representing the accumulation of heat energy. Temperature is a measure of the average kinetic energy of the molecules in a substance. Temperature tells you how hot or cold something is, but it doesn't give you the full picture of energy transfer. Key points about heat energy include: it is measured in units of energy, typically joules or calories. Heat energy flows from hotter objects to colder objects. It is an extensive property, meaning it depends on the size or amount of material. Heat energy can be transferred through conduction, convection, or radiation. Important aspects of temperature include the following. It is measured in degrees using scales like Celsius, Fahrenheit, or Kelvin. Temperature indicates how hot or cold an object is. It is an intensive property, meaning it does not depend on the amount of material. Temperature determines the direction of heat flow between objects. Let us put this into perspective with an example. Imagine we have two containers of water. Container A has 100 milliliters of water at 80 degrees Celsius, and container B has 500 milliliters of water at 40 degrees Celsius. Which one has more heat energy? Surprisingly, container B has more total heat energy because it has more water, even though its temperature is lower. If we brought these two containers into contact, heat would flow from container A to container B until they reached thermal equilibrium, even though it had less total heat energy to start with. Here is the math behind it. See the energy calculations for water in container A. Water in container A has a total energy of 33,440 joules. Now, see the energy calculations for water in container B. Water in container B has a total energy of 83,600 joules. So, despite container B having a lower temperature, it holds more heat energy due to its larger volume. Now that we have cleared that up, let's talk about how heat energy moves from one place to another. This process is known as heat transfer, and there are three main methods: conduction, convection, and radiation. Conduction is the process of heat transfer through a solid material without any movement of the material itself. It occurs when particles of the material vibrate and pass their energy to neighboring particles. This transfer is more efficient in solids, especially metals, due to their densely packed atomic structure and free electrons. Convection is the heat transfer process in fluids, including liquids and gases. In this process, the warmer, less dense part of the fluid rises and the cooler, denser part sinks. This movement creates a convection current that transfers heat throughout the fluid. Radiation is the transfer of heat energy through electromagnetic waves, such as infrared waves. Unlike conduction and convection, radiation does not require a medium and can occur in a vacuum, such as space. We will be diving into these methods in detail in our next video, so make sure you hit that subscribe button and turn on notifications so you don't miss out. Thanks for watching, and see you in the next video.